Hey everyone, good evening. I hope I'm audible. So yesterday we discussed a lot of, not lot, a couple of design problems, right? Three design problems to be accurate. We looked at how a cache works internally, and we tried to build a cache, optimal cache, which will support eviction policy based on the size. So we looked at a FIFO cache, we looked at LRU cache, and we tried to implement them using data structures, right? At the end we did a similar design problem. So we looked at a get random kind of a set. So a set having like all unique elements, but you have to find the get random means you have to get an element with equal probability. So you generate a random number, and how with an array list and a map you can build a solution like that, right? We also saw a trick there, how to maintain as many indexes per number as possible. So what we did was we swapped with the last element and then deleted the that element, right? So that majority of the characters or majority of the numbers in the array list did not change their indices, right? So this is what we looked at yesterday. Today we'll look at similar design problems. Okay, here also we will try to solve them using data structures, not with databases or such. In each problem, the trick, not the trick, the motive will be to make an as optimal solution as possible, and then we will try to based on that we will try to solve the problem, right? So let's start then. Let me share my screen. So let me know once the screen is visible and you are able to see it. Just one of you can confirm if the audio is clear, the screen is visible. Can one of you confirm if the screen is visible? Awesome. Okay, cool. So yeah, let's start then. So today we'll be starting with a, a few. We'll be starting with an easy problem, and then not an easy problem, a new type of a problem, but similarly a design problem as such. Okay, so try to think of how you can build the solution. I'll give you 5-10 minutes to think about it, but ensure you think about it in all possible directions, so that like I want the thinking ability also to increase, right? Because these types of problems are not straightforward. Yesterday's problems, yes, with double linked list you were able to solve couple of problems, at least the main LRU cache problem. But today's problems will not be that straightforward. It will not directly involve a data structure, so you might again need to use a combination of bit complex data structures. So try to think on that front. Okay, so what we'll be building today is called uh, what we'll be building today is called a max stack, right? So we'll be looking at a max stack implementation. And what a max stack is essentially is, you know what a stack is, right? So it will support push and pop operations, right? So stack supports push and pop operations. So a max stack will also support push and pop, right? Apart from that, what a max stack should support is something called pop max. Or rather, we will not have pop itself, so we'll make it simpler a bit. We want only say pop max to be supported. Okay, so what is pop max? Essentially it means that a push is simple. Push is, so you have to push the element in the stack, right? Pop on the other hand, what it will do is it will pop the most frequent element in the stack. Okay, so what does the most frequent element mean? The most frequent element means that if you have so based on the count, whichever element is the maximum occurring at that point in the stack, it will try to remove that. Okay, and if there are multiple elements with the same frequency, then it will work like a normal stack. Among those, whichever was pushed last, that will be popped first. Okay, so if there are multiple elements, so if there are multiple elements if there are multiple elements that have the same frequency, so between them it will work as a LIFO data structure, right? Okay, so this is what we will try to build. And yeah, so an example will be, say, if I have to take an example of this type of a data structure. So say I do push 1, then I do push 2, then I do push 3, then I do push 4, right? So you have basically 1, 2, 3, and 4, and then say I push again 2, then I push 5, right? So you have 2 and then you have 5. So when I do a pop now, what will be removed? So when I do pop, it will remove 2, right? Because that is the most frequent element. So it will remove 2. Again, after that, when I do pop, what will it remove?
1.
It will remove 5, because then all the other 5 elements have the same frequency, right? So among them it will behave like a normal stack, so it returns 5. Right now, say if I push 3, if I push 4, and then I push 6, right? So now I have pushed these 3. Now if I try to pop, what will it remove?
3.
No, it will remove 4, right? Because you have pushed 3, so 3 has frequency 2, then you push 4, 4 has frequency 2, then you push 6, 6 has frequency 1, so only 3 and 4 have the highest frequency at the moment. It will behave like a normal stack between those two, so you have to remove 4. Okay, so is the definition clear, all of you? So it behaves like a normal stack when there are multiple elements, not normal stack. So it will always try to return the pop the element with the maximum frequency. Okay, that is given. Now if there are multiple elements with the maximum frequency, it behaves like a normal stack among those elements. Among those elements which was pushed last, it will try to pop first, right? So now again, if I do a pop, what will it remove? Now it will remove 3, right? Because you are 3 now has a frequency 2. So everyone, is the operation of the max stack clear? What a max stack is doing here? Anyone has questions? Because the implementation will not make sense if we don't understand the question itself. So let's ensure all of us understand the question, all of us are on the same page, and then only we'll try to build up the solution. So note that we are not removing all occurrences of that element. We are removing only one element, only one occurrence of that element. That's why when you are doing the last pop, four occurs once and three occurs twice, so you remove three once. Any questions, anyone?
No, sir.
Chalo. Then try to figure out how you can solve the problem, how you can build a max stack. I'll give you till 7:50, 7 minutes. So think of what data structure you can use to solve it. Let's not think about optimal. If you can think of an optimal solution, that's great. So this is not an easy problem by any means. But even if you come up with any solution, we'll discuss that and then we'll try to optimize from there. Ideally, if you can do pop in order one time, push and pop in order one time, that will be the best case scenario. If you can do that, that is the best case scenario. If not, then also it's fine. Let's discuss solution first. I'll be monitoring the chat for any. Okay. Have one possible approach from Sudna and anyone else. You have 5 more minutes. Any specific approach you are thinking of? So note that we are not removing the maximum element from the stack. We are trying to remove the maximum frequency element from the stack. Okay, I have multiple solutions. I have one from Putul. Okay, from Harsh. Okay. So, okay, while all of you are thinking of the solution, I'll go by the order in which the answers came. So, Rudnan, do you want to explain your approach? Like, quickly take half a minute to explain it, how you are thinking to build it.
Sir, I was thinking of using a linked list where we keep track of head and tail to push in order one time, and a dictionary to keep track of the count. But the pop would not be in O of one in that case.
Pop will not be O of 1 in that case. So, you have to find out which element is maximum and then remove the last occurrence of that element, ideally.
Yes.
Okay. So pop will be actually very expensive in this case because you have to find out if there is a group of elements which have the same frequencies, then you have to search for any one of the elements which occurs at the last. So like each, maybe if you want to start from the beginning, so you have to check each element, you have to check in a set of all those maximum elements if that element belongs in the set, right? And last such element you will try to delete it, something like that. So pop will be expensive in this case. So will not proceed with this solution. So this is a suboptimal solution per se. So that's why we are not proceeding it. Putul, do you want to explain your approach?
We can use an array to store the frequency of the element. And whenever we have to element, we can check the maximum frequency from the array. And then we can pop the element. But the pop operation will be costly, like order of n it should be.
Yes, because but here you are not even maintaining like which element was inserted when, right? So if there are two elements which have the same
Okay, so
frequency,
we can take a map.
okay, you can have a map ideally. What
Yeah.
will the map have?
Map have like the element and the frequency.
The element and the frequency, okay, but still you don't know which element was passed. Like
Yes, sir.
say 1, 2, 3, 4, 5 all have the same frequency, that is 1, right? So which one do you remove
Yeah.
ideally? So you don't have that information.
5.
But say if I have done hundreds of operations, right? If I have like 1, 2, 3, 4, 5, and then like say I am pushing like this only, say at this point of time. So I had push 1, 2, 3, 4, 5, 1, 2, 3, 4, then 2, 5, then pop 2. So at this point you will pop 2 because 2 has a frequency 2, others have a frequency 1.
Yes, sir.
But at this point all
Yeah.
have a frequency 1. So you have no way to know which one to remove out of 1, 2, 3, 4, or 5. Right? And also in
Yes,
a
sir.
map, if you have to compare the frequencies, then you have to go through all the keys. So that will also
Yes,
incur time.
yes. This should be order of n. Yeah.
Yeah. So, okay, so we'll not go with that approach. So, okay, there is another solution from Harsh. Harsh, do you want to explain? So with 2 stacks, how we will solve the problem? Okay, Harsh is on mute. So we'll jump to Anand. Anand, you want to explain what you have mentioned?
Yes, sir. Like if we're pushing, then we can always check the if the uh, stack top is already the element we're pushing, then we will keep it at the top itself. And like if there is 1, 2, 3, 4 in stack, and then we will push 2. Then if 2 is already present, then we'll instead of keeping 4 on the top of stack, we'll put 2 on the on the top of the stack.
Okay.
If we pop, then the most frequent element will be popped.
Okay, but then push will now be order n, right? Because you have to
Yes,
iterate
yes,
over
yes,
all the elements to see which one element is where in the stack, and you have to update that.
yes,
Also, it
sir.
might not handle a lot of corner cases when there are say multiple elements with the same frequency. You don't know which one to remove, like which one uh, will be on the top necessarily at that point of time.
Mm-hmm. Yes.
right? So yeah. So anyone else with any other approaches? Otherwise, we'll directly jump to the solution part. No one. Okay. So the biggest
Sir,
hint. Yeah. Go ahead. Someone was saying something.
we could use a linked list like in the last case, keeping track of tail to push in order one time, and a dictionary containing a tuple of the last node of that element and the frequency with a variable that will give us the element with maximum occurrence. Whenever we push an element, we can check if the like that element has occurred more than the element having the max occurred element and update that accordingly.
But this check itself will take order and time then, right?
No, we have a dictionary storing node and the frequency.
Okay.
So we
So you
can
have a let's write it down. So you have a dictionary, a frequency map, basically which stores the some value and
a
the
tuple
frequency.
hmm,
So it has the key and the frequency. Okay. So now what you do?
and a variable having the maximum occurred element.
Maximum occurred element. Okay. So most frequent element basically,
Yes.
right? So mode at that point of time. Okay. Then what do you do?
So whenever we push an element into the singly linked list,
Uh-huh.
so we would check if the max element that we have initially,
So this one, this
yeah,
element.
that's frequency is exceeded or not.
Okay.
That
If
element
that frequency is exceeded, then what you do? Then this
we
becomes your most mode, right? The current element becomes your mode,
yes,
and you update the frequencies accordingly.
yes, and along
And
with
then
frequency, we have the link to the node of okay, link to the node, like the node in the linked list where it was last pushed.
okay,
Okay,
say somewhere
maybe a
here.
yes, maybe a double linked list
That's
would
fine.
be
We will
better.
go to the linked list later. Yeah. But then say if I pop this element, the last occurrence, say if I pop it, then you don't know when it occurred previously. So to update the map, you have to again iterate over the list and find out the last occurrence of that node,
Yes.
right? Number one. Yeah. Number two is if the mode, if you are popping out a mode, right? If you're popping out the mode itself, then maybe some other key is now the new mode. So again, you might have to iterate over the elements to get the new mode, right? So again, that pop will not be optimal,
Yes, sir.
right? So there might be some limitations like this. So this will again not be a optimal approach as such. So we'll not go with this. So let's discuss the optimal approach actually, and this is like a very it's actually a very beautiful solution. So that's why I wanted to discuss this in class itself. So the hint for the solution comes in the question itself. So the question has two parts. One is the max frequency, right? The question has two parts. So this is not a max stack per se, it is a max frequency stack, right? So we are trying to find out the element with the maximum frequency. So the question itself answers the data structures you need to use. So once is the max frequency. So the moment when you talk about frequencies, you use generally two data structures. Like whenever we talk about maximum, right? You generally use two data. Either you use a max, if it's maximum frequency, you know you have to use a map somehow. You have to use the hash map to maintain the frequencies that is given. The other part is if you are thinking of maximum, we generally also use a heap, right? A priority queue to figure out, okay, what is the maximum value. So in this case, we'll go with the hash map itself. But now in the hash map, now the other part of the question says it has to behave like a stack, right? Whenever two elements you see of the same frequency, it has to behave like a normal stack, right? So the data structure we'll be using is a combination of a map and a stack. Okay, so data structure that we'll be using is a combination of a map and a stack. So one part, as many of you mentioned, is we'll have a hash map. So we'll call it the frequency map. So the frequency map will have it will be like integer kind of thing, right? It will have the value and the frequency like we were discussing till now. So that is the common part. The tricky part here will be we have to use another hash map. We'll be using another hash map. So can anyone think and tell what will this map have now that I've given multiple hints? This is trivial, right? You have to keep the integer and you have to maintain the frequency. Can anyone think and tell? Because we have to have two things. One is a max frequency and one is a stack. So what will this map have?
A unique elements, I think.
Unique elements. You don't need to have unique elements. Awesome. So Putul has the answer. So we will have the frequency and the stack containing elements with the frequency. So Shweta also mentioned the same thing in the chat. So exactly. So we have to have a frequency, and based on that frequency, we'll build a stack itself. Because the question basically tells the solution. So the question says if there are two elements of the same frequency, it behaves like a normal stack among those elements, right? So we need to basically say, now if I take the example, okay, if I take the example on the left. So initially what we did push 1. So 1 comes in with a frequency of 1, right? So this is push. Push is exactly how do we define it? Is like order 1 operation. So one entry goes here, and what will the map have? The map, okay, another thing we need to have is the current max frequency, not the element, just the current max frequency value. Okay, so initially it will be 0. The moment we see that we have a frequency 1 which is greater than the current max frequency, we update it. We make an entry in the map saying that 1 and an empty stack. Okay, everyone good with this? So empty stack, because it's a map, I'm writing it from left to right like a normal this thing, but it will behave like a stack itself. Okay, then 2 comes in, push 2. So these are the set of operations I'm doing. So the set of operations are basically here on the right hand side, right? So push 2 I'm doing. So 2 comes in with a frequency of 1. Max element does not get updated. So because the max element, we already know something is already there, right? So we check here in the map, whatever is there, we push. So 1 was here. This is the top of the stack on the right, you can assume, right? Right side is the top of the stack. 2 has now been inserted in this stack. Then 3 comes in. Frequency 1, 3 goes in this stack. 4 comes in. Frequency 1 goes inside the stack, right? Or everyone okay with this approach till now? No questions? Awesome. So now the tricky part comes in. So 2 comes again in the stack. Well, 2 is pushed again. What do? We update the frequency of 2. The moment we update the frequency, obviously we are always checking if it is greater than the current frequency. Yes. The moment we see it's greater than the current frequency, I know that this stack is not yet there, right? I make a new stack with this frequency. What do I push in here? I push 2. I push the element, right? Note that I'm not removing this element, this 2. Because why I'm not removing this element? Now let's try to do a pop. Okay, there is another push. Let's do that. So 5. Count is 1. So I'm pushing 5 in the 1 frequency stack. Now I'm doing a pop. So the moment I'm doing a pop, what I'll check, can anyone tell with this design, if I have to solve it in order 1, can anyone tell what I'll do?
Find the element with current max frequency in the frequency.
Do we need to find the element with the current max frequency?
It was maintained in the second.
It is maintained in the stack itself. So we just need to see the current max frequency, whatever it is, right? We just need to say what is the current max frequency. We know it is 2. So we directly go to the 2 ka key. This is a map. So order one thing to check the stack and we just pop. So we pop 2. The moment we pop 2, we also check whether this map is empty. If this map is empty, we delete this element altogether. So we delete this element because this stack has become empty, right? So we pop 2. So this pop works correctly in order one time. Next pop comes in. Next pop happens. So and this has now been updated because the stack was empty. We have made current max frequency as 1. Okay, so multiple operations. I'll list them down. I'll note them. Now again I have to pop. What is the current max frequency? 1. I check in the map. What the key 1. I check in the stack. I just pop. So 5 is popped. Order one time. Right now I have to push 3. Okay, this also got updated. Now I have to push 3. So what will I do? Now can anyone list the steps clearly for a push? What I need to do? What all things?
First, we will update the frequency 3, then update the current max frequency, and we will create new stack in the second map with frequency of the current max frequency.
Awesome. If there is no stack, we will create a stack and put it. If a stack is already there, we'll just push it in that stack, right? So if I have to push 3, I'll update the frequency. This is step 1. Then what I have to do, I see this is the frequency now 2. I'll check with the current max frequency. I see it was 1, so I have to make it 2. And then I know that because I made it 2, there is no stack available, so I create a stack and push that element in that stack, right? So push is done in order 1, 3 operations only, constant. Now I have to push 4. Push 4, what I'll do, same thing. I'll do 2. I'll check my current max. It is already 2, so I know a stack is there. I just insert it in the stack. Pushing in the stack order one time. Now push 6. A new entry comes in the frequency map. 6, 1 is less than 2, so I don't have to worry about a new stack. I just go to the 1 stack and I insert it. 5 has been removed, so I insert 6. Right? Then pop. So now I have to pop. So now can anyone list me the steps for pop? What I have to do? Anyone? How do I remove pop and ensure in this case that we are popping out 4? No one?
Sir, we check the
Pop
max
the
frequency.
stack at
We check the
current max
current max frequency, then go to that frequency stack map and push the last element. Oh, sorry, pop the last element of that frequency stack.
Okay, then
Then check if the stack is empty or not.
if it is empty, what we do?
We decrement it by 1.
We decrement the current max frequency by 1 and we delete that key also from
Yes.
this thing, right? So okay, so we check the current max frequency, that is 2. We go to this map, we check the stack is there, we pop 4. We'll pop from the top, so 4 will be popped. We'll check if this stack is empty. It's not empty, so that means there is at least one element with frequency 2, so we don't update the current max. Now we have to again pop, so I'll take the same logic. We check the current max frequency, it is still 2, so I go to the stack for 2. I see there is 3, I pop it, right? I pop it. So this is done in order 1. Now what I do, I check, okay, if this stack empty, if the stack is empty, I can't do anything. I'll delete this element and I am ensuring that there are no other elements with frequency 2. So I update the current max frequency to 1. So next time pop happens, what will be removed? So if there is a pop again here, what will we remove?
6.
We'll be removing 6, right? Because that is the this element basically. Yeah, 4. After that there is 6. So this stack, this element we will remove. Again, if I have to remove, then I'll remove 4. right? Because now all elements have one frequency. Okay, so this is the logic for creating a max frequency based stack. Okay, so I'll just write the code for this one. Think I'll reshare my screen with the editor. I think I'm not sharing the editor, right? Just sharing the OneNote, or I'll just code it up here itself. So let's do that. So I'll have a, I can start from here itself. Second. Yeah. So I'll have a hash map with, say, integer for the frequency part, right? So I'll call it the frequency map, or let's call it fric for now, because OneNote does not support auto addition later IntelliJ. So I'll just keep the variable names short. So this is a map, and then the other map I'll have is with an integer and a stack. Okay, and the stack will also be again of integers only, right? And say this, I'll call it say a stack, a frequency stack kind of thing. So it will again be a map. It will again be a map, right? And then I'll have another thing called the current max frequency, which will be equal to 0. Okay, so when I do push, so I'm not writing void and all these things. So when I do push, what I'll do first, I'll be checking whether that element, I'll be updating the frequency map first, right? So I'll be updating the frequency map first. So I'll be checking that curve frec, whatever the curve frec is. So what I'll do is I'll do frec dot get or default, right? What I'll do, frec dot get or default, I'll get the current frequency, whatever the frequency is. So when I do push, I have to put an integer, some int x. So I'll do get or default x 0 plus 1, right? So this will be the new frequency. If this is the new frequency, I'll update the map. I have to update the map anyway, so I'll update it with, say, x and curve frec, right? So this is how I am updating the frequency map. Now I will be updating the curve max frequency value, right? So it's very logical, step by step we'll do. So once we update the map, we'll update this value. So what I'll do, I'll just do map.max, max of these two things, this and frec, this curve frec, whichever is bigger, that value gets assigned to it, right? And then what I do, I just check if the other stack, if the other map does not have this element, right? So I can just check if this dot contains key curve max frec, right? If this dot contains key, if it is not there, oops, click some shortcut, yeah. So if this is not there, right, if this element is not there, if this frequency is not there, so I have to create a new stack, right? So I have to create a new stack. So what I'll do, say map.put, and what is the map name we have? So we have st.put, and what will I put here? The key will be the current max frequency. We can do this for curve frec actually. It will be easier. If it does not contain the key, then we'll create, then we have to create a map, we know. It will be the same thing actually. And we will create a new stack as the value, right? A new empty stack will be created. And after the new empty stack is created, I have to just insert it. So I'll just do st.get curvefrec dot add. I'm adding it in the stack, right? I'm adding the value in the stack. Bus, that's it. So what did I do? I found the curmax frequency. Then I checked whether the curvefrec it is there in the stack or not. That means whether a current frequency stack exists. If it does not exist, I create it. If it exists, I add it. If it does not exist, I create it and then I add it. Right? So this is just 4 or 5 operations. So it is always constant. So push is order one time. Now for pop will have to have an int, right? So what will pop have? What will we do first? We will remove the element first. So we will say int element equal to stack dot get. I'll get the stack associated with the curmax frec, right? This is the stack. When I do get, I get the value. That value is the stack itself, and then I pop it from the stack, right? So I have popped it from the stack in LE, and then I have to update the frequency map. So I update the frequency map frec dot put. So what will be the key? The key will be the element itself, and the value will be the count of the element. So we already know that the count of the element is curmax frec, right? So we don't have to query the frequency map. We can directly know it is curmax frec -1 because one element has to be removed, right? Then what do? We check if the stack is empty or not. So we'll check if the stack is empty or not. So we'll check if stack dot get dot size. So if the stack is empty, then I have to delete that element, right? So I'll delete that element. So I can just do st dot remove that this key and the value basically, right? I can remove this and I have to update the max frequency also, right? I have to update the curmax frequency also, right? And at the end, obviously, because it's a pop operation, I'll be returning the element itself. Okay, so whatever steps we discussed, this is how we are putting them in code. So this is the frequency map that we discussed. The frequency map, not writing it anyway, it's self-explanatory, right? This is the frequency map and this is the map of stacks. So this is the curmax frequency value that we saw, and this is order 1. Why? This is order 1, this put is order 1, this max is order 1, contains key is order 1, and put again is order 1, creating a stack order 1 time, and this add, because you are adding the element on top of the stack, so everything is order 1, right? So this is done in order 1. And pop also, so get and pop order 1, remove, putting into a hash map again order 1, and then deleting this comparison, so again order 1 time. So pop also occurs in order 1. So this is how we implement a max frequency stack. Okay, so we dry run it already, so I'm not going into dry run again, but any questions till now? No questions? Okay, so let's move ahead. So this is a very, very beautiful problem. This is not at all an easy problem to solve, right? So if you get in the interview, if you have prepared well, it should be easy to solve. If you're not, then it's very difficult to come up with it like on the spot, right? But many of you could come up with an order and approach, so that's great. But if you are given this type of question, the expectation will be that you can come up with an order one approach, and that's where these solving these types of problems beforehand makes help. So now let's try to build something like a uh, uh, let's say we'll build something like a traffic system. Okay, say a train system. So we are now trying to build a train system. So let's say the problem is we'll design a so what does a train system have? Say it will support like board check-in and check-out operations. Okay, check-in means a user ID, some train ticket, some ID, right? We'll be checking it at some station. Okay, say it checks in from station and some timestamp. Okay, so this is say a check-in functionality has to be assigned. Then there'll be a checkout functionality. Checkout will again be some user ID. He has got down and got out of the station, so some to station, and some timestamp will be there. Okay, so check-in and checkout is done, and the other two things that we need to find out is say get average time between station A and station B. Okay, and the other thing is we need is total time, total travel time for a user. Okay, so we need total travel time for a user. So what happened? I think we just add this. Yeah. So total travel time for some user ID. Okay, so these are the four functionalities you have to solve for: check-in, check-out, get average time, and total travel time. Okay, so the same question: what kind of data structure will you use, and how do you implement check-in, check-out, get average time, and total travel time? So another thing you have to note is get average time from station A to station B can be different from get average time from station B to station A, right? Because the train routes might not be same. There might be problem in one particular rail and all these things, right? So get average time A to B might be different from B to A. So your data structure should handle that. So we'll be making repeated calls to check in and check out with these three parameters. How do you solve the problem? What data structures will you have? Data structure or group of data structures you will need if you want to get things in order one. Okay, so if you are looking for an example, so while you think about it, so the example can be like, say I'm making calls, say I'm making calls to check in some user ID, say ABC station 1. He has checked in at say 10 a.m. So at the timestamp you can consider as integers, the user ID as strings, and the from station also as strings. Okay, then I do check in user X from station 3 at say time 11, then check out user ABC at station S5 at say time 15, and then say check in user DF from station say S2 to or say S3 at time 20, and say then check out DEF at say S4 at time 22. So at this moment, if I have to do get average time between S1 and S5, so there is only one user between S1 and S5, so you know the answer will be 5, right? He checked in at 10 and he checked out at 15, so this answer will return 5, right? And then say again there was a checkout by this user, say by X at say S4 at say time 25. Okay, then I do get average time, say I do get average time from S3 to S4. So there are, now you can see there are two users, X S3 to S4, right, at 11 and 25, so 14 plus this DEF from S3 to S4, 20 to 22, 2, 14 plus 2, 16 by 2, so this will give me 8.0 rather, because it can be decimals also, right? So this is the example I could come up with quickly. Okay, so there'll be multiple calls for check-in, checkout, and as along with that get average time. Okay, so I'll just explain the question again because some people got dropped off in between. So basically we are trying to build a train system, okay, a metro system, you can call it a railway platform system, whatever, where users are checking in and checking out at different stations at different points of time. You have to figure out get average time between two stations and total time for a total travel time for a particular user. Okay, so you have to design data structures such that you can get average time and total time in order one. Okay, so on the right hand side you can see it's a dry run kind of thing. So user ID and station numbers, station names are basically strings, and the timestamp is given to you as integers. Okay, so let me know if you want an explanation. Again, I'll go with a detailed explanation. Otherwise, if you have to solve this problem, what will you use and how do you get everything in order one? Okay. We have no answers in yet in chat, so we'll give only 4-5 minutes for this. Okay, so till 8:30 resume, we'll wait and then I'll explain what we can do. But try to rack your brains on how we can actually solve this problem. Anyone? Any initial approach? No one with an approach yet? So shall we discuss? So the easiest hint that you can get is the get average time part. So you are given two stations and you need to get an average time for that. So what data structure can you use to get that optimally? Anyone? So if you have to get something in order one time, what will you use? So we'll use a hash map, right? Awesome. So we have to use a hash map where the key will be the combination of two stations, right? That we know. So it has to be, right? We have to get because SA comma SB. So you cannot have two keys in a hash map. That's not possible. So the hash map will look something like this. It will be like SA colon SB kind of key you will have, and the value you will have the get average time. So how do you get average time? So what will you keep the value such that you can get average time in order one? So this is the key, the combination of stations. So what value will you keep? Anyone? What will be the value such that you can do get average? Yes. Anyone? How can we get the average in order one time?
Sir, sum comma n.
So we'll have to have a pair as the value, so we can have sum comma n. Perfect. So this is the sum and this is the n. Why do we not have the average directly? Because later if something gets added, we need to continue add to the sum, right? So we have a long sum kind of thing and we have an integer n or long n, whatever, right? Then what else do we need? How do we handle check-in, check-out? How will we handle check-in, check-out? Anyone? How can we do the check-in, check-out part now? So we figured out how do we do the get average time. How do we handle the check-in, check-out optimally? So you can see that each user will check in once, and unless he checks out, he cannot check in again, right? Obviously, because he's going from one station to another station. So he has to check out, then only he can check in again, right? Otherwise, he doesn't need to check out in between a journey. So we can have something like we can have, because we have to do it optimally, so we can have another hash map. We can have another hash map where the key is the user ID, right? And the value will be the station and the time, onboarding time. Okay, so I have say in station, wherever he checked in, and the in time. Okay, so whenever I find the in station and in time, I add in the map. And whenever I see a checkout, I see what was the check-in, I see what was the in station, and I see what is the out time minus in time. So I know what is the total travel time. So out time minus in time will be the travel time. So I remove that element from the map and I add it here. So I say that in station colon out station, sum will be added by out time minus in time, num will be incremented by 1, and this element will be removed from the this map. Another map we have to have for the total travel time for that user. So we will have another map saying user ID, and you will have total time. Okay, so we need 3 maps to solve the problem. One is for the get average time. So the get average time will basically have station A colon station B kind of thing, that is in station colon out station, and the sum and the n. You will have a second map for the ongoing journeys. So the second map is for the ongoing journeys. So this is the second map. This is ongoing journeys. So whenever a journey ends, you have to remove that user ID from that map, and you have to calculate out station minus in station, whatever the time is, you update here for the user, right? What you do update, you do sum plus out minus in, and you do n plus plus, right? So you can get the average at any point of time directly from this map, and total travel time for the user you can get directly from this map. So this is the total travel time map. So we have 3 maps. One is the ongoing journey, one is the total travel time, and one is the uh, get average time, for the get average time of a particular station, right? So with this you can do all the operations in order one. Okay, so this is a fairly simple problem, and you can do it directly using maps. You don't need to use any other data structure per se to complicate it. Okay, so whenever you see questions where get has to be done in order one, you know that you have to use a map, right? Whenever you see that get has to be done, there are 2 gets here. One is get average time and one is get total time per user. So you know that get has to be done in order one kind of time. Okay, and you have to use hash maps for that. Okay. Awesome. So let's solve one last question. So any questions till now? Nothing, right? Awesome. So we'll solve one last question. So let's think what I can. I'm just thinking of what else to cover in this genre, because we'll not come back to designing stuff anymore. Okay. So we'll be designing one last thing. Yeah, this is a good problem that we can solve. So we'll be trying to build a browser history kind of a class now. Okay, we'll be trying to build a browser history kind of a class. So if you remember, if you note that in a browser we have two history buttons, like go back and go forward kind of thing from the current page, right? So that is what we will try to build. So you will have a browser history class which will have a constructor with the home page. Okay, and you cannot go back from the home page, so you directly know what is the home page. Okay, so you cannot go from the home page. And then you will have two things. One is a visit, so that will return a string of the current visit. So when you do visit, it doesn't need to return actually, so it will be a void. So you are visiting a new web page basically, right? So when I do visit some web page, say some URL, so that URL has to be visited, so your cursor will jump to that URL. Okay, and then you will have two functions called, say, back and front. So you have back, say int x, int steps, basically how many times you want to go back. So this has to return what is the URL that you visited five times before this, right? How many which URL you visited after which you did 5 visits and came to the current URL. So you are moving across the browser. And then you will similarly have something like string front, or so one is back and one is, say, next kind of thing, or forward. And again you have something like int steps. So you have to think, okay, what will I get if I go 5 steps or x steps forward? Okay, so if steps are greater than the total URL visited, you will stop at the home page. You will not go before the home page. Similarly, in the forward case, if steps is greater than, so you will remain at the last page, the most recent page visited, whatever it is, right? So I'll give an example for this. This is not a straightforward problem. So say I have something like a browser history class. So say I have initialized browser history with google.com. So Google is my home page, right? Then I do visit Facebook. Then I do visit LinkedIn, right? LinkedIn.com. Then I do visit wikipedia.com. Okay, then I do back 2 steps. So what will be my return? What will be back 2 steps, anyone?
Facebook.
It will be facebook.com, right? So you have to return fb.com. What will be forward 1 step?
LinkedIn.
Yes, so you have done back 2 steps. That means you have gone back to Facebook. Now you do forward 1 step, you reach at LinkedIn. Now say I do visit. Say I do visit, say LeetCode itself. Okay, the moment I do visit LeetCode, Wikipedia is now gone. There is no memory of Wikipedia because from LinkedIn I have come to LeetCode. So if I do back 4 steps, where will I, or back 2 steps, or back 1 step, where will I go? Let's start with back 1 step. So what will be returned for back 1?
LinkedIn.
Back 1 will be LinkedIn from LeetCode. Now from LinkedIn, if I do back 5 steps, what will I get?
Google.
So from LinkedIn, back 1 step would have given me Facebook. Back 2 steps would have given me Google. After that, whatever back you give, because you cannot go back from the home page, you remain at Google, right? if I do forward 5 steps, what will I get? From Google, forward 1 step will be Facebook, then it will be LinkedIn, then it will be LeetCode, and we'll be stuck with LeetCode after that. Right? So now obviously the obvious question, how we can build this type of a design, how we can build this type of a class, browser history class.
Sir, we could use a double linked list.
Okay, and then
The head would contain the home page when the user, when the constructor is called, and in the visit we add in front of the linked list at the tail position. For forward, we could go back the mentioned number of steps, and if the temporary pointer is equal to head, then we stop at that position. And
okay,
for string forward, we go back from the tail, like the tail is keeping track of the current website we are in. If we go back and then go forward like 3 steps, like from LinkedIn or LeetCode, it would stop at tail position.
okay. So how do you handle this part that Wikipedia is now gone from the history?
So
So say you are somewhere in the middle of the list and then you do a visit.
from that we have to like take 2 pointers, keeping track, move the tail to like from LinkedIn, we visited LeetCode. So LeetCode is the new tail. We take 2 pointers and make the forward like pointers in the the forward nodes. We make all of the links null, so it would be collected by the garbage collection, and then add LeetCode to the tail.
Okay, so in the current place itself, you can directly create a new node and just put currents next to the new node, and that's previous to the current. And the remaining elements, because now they cannot be accessed anymore, all those elements will be removed. So you don't need essentially 2 pointers if you're using a double linked list, right? Because all those, because they are now, they cannot be accessed from your code, they will be anyway, that memory will be deallocated at some point of time. So
Yes, sir.
with a double linked list, you can solve this. Any other solutions? So what will be the time complexity of forward and back with this case?
Like n maximum would be the length of the list, like when the
Length of the
steps.
list, or basically steps, order of steps or order of n. Yeah. Okay. So yeah, any other solution? I think you cannot do better than this maybe, but any alternate solutions anyone wants to think of. So everyone got the approach. So with a double linked list, we can create the head of the double linked list as the home page, right? And whenever we visit, we create a new node and add it to the end, and that becomes our tail, right? So the tail contains the current node, and whenever we go back, we only go back till the head. We don't delete it, right? We don't delete anything. And once we go forward, we always go forward in the linked list. But if I do a visit from somewhere middle, then I don't need the forward ones anymore. So I create a new node, and remaining ones I just set to null, basically, and that new node becomes the new tail. So current points to that new tail, and new tail's previous points to current. Done. So this is a pretty good solution. Okay, Shivam has an approach. You want to talk about it, Shivam?
Sir, I was thinking of using a dictionary. So it
Mhm.
will, the key value will store the page number and the and the value will store the URL. So the zeroth for zeroth, I will keep the home page,
Okay.
and I will keep two variables which will check if we call for the visit, then the first variable will be point to that position where the visit is currently.
Okay.
So uh, uh, so if fb.com is called, then as our pointer is at zeroth position, we will increase it at 1, and we will put the page number and the URL in the dictionary. So 1 and fb.com will be stored in the
Okay.
dictionary.
Then you
And
get LinkedIn. So 2 LinkedIn.
yeah,
Then you get Wikipedia. 3
yes,
Wikipedia. Like this, you are adding in the
yes, sir.
hash map. Okay.
Yes,
Then
sir.
you do back 2.
Yeah.
So
So at this position, I will check if the current means if the variable, let's say is the name of the variable. So if a minus 2 is less than 0, then I will return.
zeroth
Then
element only.
yeah,
Okay. And if it is greater than 0, you return that
and I
particular
will,
element.
yeah, yes, sir.
Okay. So now back is optimized. Back is order 1. Visit is order 1. So
Mm.
how do you handle how do you handle a scenario, say from 2, like 2 was your LinkedIn and 3 was Wikipedia. Now say from Wikipedia I've gone back to LinkedIn and I have, say, visited LeetCode.
Yes, so when I get back to the current variable, the variable a is pointing to that LinkedIn position,
Mm-hmm.
but I will keep another variable also which will check the maximum number of pages we have visited till now.
Okay.
So if we go to forward, and if it exceed the uh, second variable value, then we will return the values of that second variable from the dictionary.
Okay, so this is not very clear. So I think apart from that, the approach seemed pretty good. So let's say I'll just write this approach itself. Okay, so what we'll have essentially is, here, say you have the key values, so that everyone is on board with the approach. So we have a key value thing, and we have one variable called, say, the current page kind of thing. Okay, so when I do homepage Google, so I say that key is 0, and this is the value is google.com, and current page is 0. Then I do visit, so this is FB, and current page is 1. Shivam, am I explaining correctly? So this is what you are saying?
So also we are taking another variable which is checking
Yeah,
the
we'll keep another variable also. So we'll come to that. So we'll just do the visit part first. So we do
okay.
LinkedIn. So we have LinkedIn, then we have Wikipedia. So till now everyone is okay. So when I do back 2, I know, okay, this current page gets increased. So when I do back 2, I know 3 minus 2 is 1. 1 is greater than 0. If 1 was less than 0, I would have returned 0. But I know 1 is greater than 0. So I update this to 1, and I say, okay, I'm at Facebook. Right? So this is order 1. Then I
Yes, sir.
do forward 1. So I make it 2. I check, okay, 2 is already there. So I say LinkedIn. Right?
Yes, sir.
Yeah. What the other variable you will have?
So it will store last position.
The max page.
Yes, sir.
Okay, the max page number at that point of time.
Mhm.
So if I do, if from here, if
So
I
max
do,
page will always be updated whenever visit will be called.
correct. So max page is, say, 3 for now. Is it, or you want to update?
Yes, sir. It's 3 right now.
It's 3. It is the maximum page value key that we have. Okay. So when I do, say, from here, I do forward 10 from LinkedIn, what will happen?
It will return the value of max page.
Yeah, so it will do 2 plus 10. It will see that 12 is greater than the max page. So I know only till 3 there are values in the hash map. So I return Wikipedia and update current page to 3. So that part is handled. Now say I was at LinkedIn, and say I was at LinkedIn, and so current page was 2, and I do and say there was another thing also, say for LeetCode. Okay, and say I do visit YouTube from here, from LinkedIn. Okay, so when I do visit LeetCode, when I do visit YouTube, what will happen from LinkedIn?
So that current page position will be increased to 3, and max
Okay,
page will also be changed to 3.
okay, and
Yes,
this value will become
yeah, that will be changed to lead code or
YouTube.
YouTube, whatever.
YouTube, yeah.
Yes, sir.
So
Yes.
now when I do forward from YouTube, then you will hit an issue.
No, sir. Max page is position is 3. So maximum
Okay,
we have till 3 only.
okay. So maximum, because maximum position page is 3. So you are saying that anything beyond that will anyway get ignored, and this is what the value you will get.
Yes, sir.
Right? Awesome. So this is an even more optimal solution. So we have a solution with order one order one time for both forward and back. So this is like a pretty good solution, but you have to have two variables associated, right? So this problem is already there in LeetCode. So just search for browser history, okay, and try to implement it, all of you. So we have discussed two approaches, one with a double linked list, which is a acceptable approach. It's a good approach. So it takes order steps or order n time, the size of the linked list, but it's a good approach. Okay, it will get accepted. The other approach that Shivam mentioned was with a hash map. So that looks like an order one approach. I want Shivam, please implement it and see if all the cases are getting handled, right? Because I have not solved it with
Okay,
this
sir.
solution. This looks pretty novel. This is actually a very optimal approach, but there might be cases it might get missed. So do solve it up. Looks okay to me in the naked eye when we are dry running it, but do solve it up. Okay. So the both the problems that we discussed, this problem that we discussed, both the approaches you can, like, all of you can try it out. So there is also another approach using two stacks. So the back, basically you can use a stack and solve it up, and the forward you can have another stack for the forward pane. When you do a visit, you empty the forward stack, basically, right? So that is a third approach for solving the problem, but that again is order n or order steps kind of thing in the worst case, right? So try to solve this problem in LeetCode itself on the portal, so you'll get to know which one has the like efficiency wise you are doing good or not, because the times and everything you get after submitting the solution. So yeah, that is what I had in my mind for today. So I think we covered all the three important questions. One is browser history, one is the train system. This is by far the simplest one of the three, and the third one, the most complex one of the three, is the max frequency stack, right? So yeah, this is what I had in my mind. And so now tell me any questions, anything on your end before we wrap. No questions? Awesome. So okay, we'll wrap them. If you have any questions, use the group, leverage the group, feel free to add stuff, and we can take it up next week. Otherwise, the next week my plan is so this week we discussed more about design problems. Next week we'll come back to like data structure based problems, sorry, pattern based problems. So we have discussed the two pointer pattern. We'll look at other patterns also. Okay, so we'll meet again on 30th, and 30 and 31st we'll have the next two classes. Okay, cool, thank you. Yeah, have a good holiday week, and yeah, bye bye.